A very typical problem in calculus is you're given the graph of a function and asked to create a graph of its derivative. So here's an example of a function. My function f of x, we can see its behavior, and our task is to create a graph of f prime of x. First thing I'm going to do is just remind myself what the basic steps that I want to think about are. So first, we're going to look for where the derivative equals 0. So we're going to find all points where the slope is 0. This is because where the slope is 0, that's going to be some spots where the f prime function crosses the axis. Second, we're going to look at the sign of the slope. And that's because where the slope is positive, my graph will be above the axis, and where the slope is negative, my f prime graph will be below the axis. And the third thing that I'm going to look at is I'm going to look at my concavity and sort of the end behavior. This is because where my graph is concave up, my slope will be increasing. And where my function f is concave down, my derivative, f prime, will be decreasing. All right, let's give it a go. First, we're going to identify spots where the slope is 0. These are where I have a horizontal tangent. So I have 3 points where I have a horizontal tangent line. Those are going to be at 3. I've got the derivative equals 0. At 0, my derivative equals 0. And at 3, my derivative equals 0. All right, next we're going to look at the sign of the slope. So to the left of 3, I can see that my slope is positive. Slope is positive. In between negative 3 and 0, I can see that my slope is negative. Then it'll be positive. And finally, it will be negative again. All right. So now we know where I'm above and below the axis. Third, we're going to look at concavity. At the beginning, I can see that I'm concave up. And at some point I switch to concave down. And that point where I switch is going to be the steepest point. So let's say that this is my steepest point. That corresponds to an inflection point. All right, so then I'm concave down, and at some point I switch to concave up, and somewhere in the middle, let's say somewhere in here, again I have an inflection point. This is where it's the steepest. And as I go through, there's a spot where I switch from concave up to concave down, and from concave down back to concave up. Looks like maybe for symmetry, let's put it about here. So these are my inflection points. All right, now what we're going to do is we're going to take this information and create a graph based on what we have. All right, let's start by creating our axes. We know that we have our places where my derivative equals 0 at negative 3 and positive 3 and at 0. And so these are the 3 points where my derivative equals 0. Then to the left of 3, I'm above the axis, so I'll be above the axis, then below the axis, then above the axis, and finally below the axis. And now let's take into account our extreme slopes, our steepest slopes. And so just past negative 4, just maybe a little bit past negative 4, I reach the highest positive slope. So this corresponds to the slope, the slope value. And if I thought about what that means, there would be a tangent line. Let me change color. There would be a tangent line here. That looks like it's about a slope of 1. So if I actually literally wanted to think about how high that was, right, that would be my slope value would be a height 1. And what's happening? My graph is increasing to that point, and then it turns around and comes back to 0. Okay, now notice that at the ends my slope is getting closer and closer to 0, And that's why I've brought my graph to be coming down towards 0. All right, between maybe at negative 1.5, I have an extreme negative slope. And I could maybe in principle calculate what that slope was by thinking about my tangent line. Maybe that's at a height negative 3. Okay, so my derivative comes down, and then it goes back towards a slope of 0. And then the other side is actually going to look like a reflection of this. I reach a highest positive slope, come back to 0, and then I get negative slopes, and where this extreme slope would correspond to something just past positive 4. And this is what the graph of f prime of x would look like.